The medical world came with enormous resistance. So the first one was in the media, was to make everybody know or believe that the future is with embryonic stem cells. And that's what a lot of people believed in the first part of the year 2000 until 2013, 15. That's what most people thought. And it was misguided. It has never been, the future has never been with embryonic stem cells.
Welcome back to Longevity Roadmap, everyone. And as you may or may not know, I went to Colombia. I went to Medellin to BioAccelerator back in January. Now, BioAccelerator, you may or may not have heard of, but it is it's a company that essentially it's an American company based in Medellin for the purpose of therapy with umbilical cord mesenchymal stem cells. And I had my hips and my back injected. I've got these odd labral tears in my hips, which basically, if you don't know, it's kind of like the meniscus of the knee. It's like, and so I've got these tears, and I don't know if it's back from my hockey days or what, but they were getting really achy, and the joints themselves were fine apparently. But apparently that's, not terribly uncommon. So I had that. And then my back has been a problem really since I was 15 years old. And I was just trying to get something done there. Anyway, so I had a bunch of stem cells injected into the area of the hip labrum, like in the joint area, to bathe it there. And with the back, they did a bunch of intradiscal injections. And they also injected stem cells into the joints, like the joints between the spinous processes, and anyway, I don't need to go into too much of that. But bottom line is, it was pretty intensive, and so that was in January. How do I feel now? Well, they told me it would be about 3 months where I would really start to, feel a difference. Now, some people say they feel it right away, which doesn't really make sense to me. The way these things work, it should require time, and it did. So I wanted to sort of give an honest opinion of that. As far as my back goes, my back's always kind of been bad. But in the reality, in the last 4 months, I really haven't had any flare-ups. So, I mean, I can't say it's 100% because of those stem cells, but certainly had those stem cells and I had no flare up. So that's definitely a positive. I think overall I'm having, I think less about my lower back. So that's a good thing. The hips, interestingly, that was really bugging me. Okay. It was like really achy. And so I could definitely tell that. Do I still have some aching coming from those labral tears? Yes, I do. But I would say it's probably about, I'd say 75% better. And that's kind of a big deal because that was something that was really bugging me. It was really, really bugging me. I've not had any follow-up MRI images or anything like that. And also I should point out that, as of this recording, it is almost May 1st. So now we're talking about, February, March, April, May, like 4 months, right? In entirety. It's supposed to continue to get better for a little bit longer. So we'll see what happens. But if you're curious, you want to know more about what I did there, you can always shoot me an email, buck@longevityroadmap.com. And if you're not on the email list, by the way, maybe you should go to longevityroadmap.com and get on that email list. I know we send little summaries out there every week, and it's also a good way to get back to me as well. I have, if you're interested in that opportunity in Medellin, I do have like a discount code I can potentially send people to. I believe it's like 10%. It's very expensive. You should just know that right off the bat. It's expensive. I was lucky in that I did get, as a podcaster, I did get a significant discount. So anyway, now the reason I went down there again was because these mesenchymal stem cells from umbilical cords, you can't do that in the U.S. really. There are these, I don't know, they have these like Wharton's gel kind of voodoo things out there that I don't have a lot of faith in. But, if you want straight up fresh, embryo or straight up mesenchymal umbilical cord stem cells, you're going to need to go to a place like BioAccelerator. And I have always believed, and maybe I continue to believe until I have more proof otherwise, that these younger stem cells are more effective than potentially adult stem cells. And what I mean by that is you can harvest adult stem cells from yourself. So you can get adult stem cells from your own adipose tissue, from your own fat tissue. See, in theory, you can get liposuction, and if that person knows how, get them harvested, get stem cells harvested, or even multiplied and inject them back into you. That's something you can do. I didn't really think that was worth it before until I spoke with Christian Drapeau, who I am interviewing this week, and we'll have that interview in a second. But his point is that, frankly, there isn't really a big difference in terms of effectiveness. Now, if that's the case, that's kind of a big deal. He talks about some other things as well. We can get into that. But I think one of the big things that I think I'd like to draw your attention to as he tells us about stem cells is, gosh, maybe you don't have to go to Columbia. Maybe, you can potentially get a good benefit, maybe for even a lot cheaper. Who knows? Harvesting your own cells, doing stuff like that. I'm not suggesting you do that, by the way, but it is worth a conversation, worth a thought when you hear what he has to say. So when we come back, we'll have that interview with Christian Drapeau.
Hey, longevity enthusiasts, it's time to take it to the next level. I've been fine-tuning my longevity regimen for years, and I look better and feel better than I did a decade ago. In fact, my blood work is even better than it was back then. And it's all because of my data-driven regimen. And it's inspired me to create a course and community just for you. It's called the Longevity Roadmap, and I urge you to check it out. If you're tired of your belly fat, tired of being tired, or just want to optimize yourself for the next 50 years, visit longevityroadmap.com. That's longevityroadmap.com.
Welcome back to Longevity Roadmap. Today, my guest is Dr. Christian Drapeau. He's a neurophysiologist and stem cell researcher with over 30 years of experience in medical research, including 20 years dedicated to stem cell science. He's earned a bachelor's degree in honors neurophysiology and a master's degree in neurology and neurosurgery from Yale, where his thesis focused on elliptogenesis and long-term potentiation. He is focused on the field of endogenous stem cell mobilization, a concept he's introduced to describe the body's ability to release stem cells from bone marrow for natural repair and regeneration. He is the founder and chief science officer of STEMREGEN, where he developed plant-based supplements designed to enhance stem cell activity. He was also the author of the best-selling book, Cracking the Stem Cell Code. Welcome, Dr. Drapeau. How are you?
Very good. My pleasure.
Well, I would like to do here, if you're okay with it, since you are, your background is initially as an academic, and I like to make sure people kind of understand some of the science before we get into some of the effects, is let's talk a little bit about stem cells. If you would, I think people in general who listen to this show are interested enough. They have this concept of stem cells being these, progenitor cells, but perhaps you could talk a little bit about the difference between what we think of when we think of embryonic stem cells, when we think about adult stem cells, even mesenchymal stem cells, which are somewhere in the between.
Correct. So you want me to describe these different types of stem cells?
Yeah, if you wouldn't mind.
So I think a good way to talk about them, to understand what they are, because more than understanding what they are, I think what may be confusing to people oftentimes is our evolution of their knowledge. What we thought 20 years ago is not what we know today. And there's a lot of this older knowledge, if you want, that is still lingering. So the power of stem cells, let's say embryonic stem cells, had been known for quite some time. In the whole field of embryology, we know that if you have the egg that couples with the sperm, it gives, the first cell, the zygote. It's developing into a lump of cell called the blastocyst. And from that lump of cells, these cells are embryonic stem cells. If you take one of them, you can recreate an entire organism. And that's how clones were made. People remember probably Dolly the sheep, and they did the same thing with dogs, mice, a lot of animals. So the knowledge of the power of embryonic stem cells has been there for quite some time. But the idea was like, could we do this with humans? Because if we can, that means we can regrow a heart and then give person a new heart. So that was sort of the dream. But nobody has been able to develop or grow embryonic stem cells until 1998, which is really the birth of what we call today as really stem cell research. Until that time, we knew that we had a type of stem cells in our body, in the bone marrow, that made blood cells. They're adult stem cells in the bone marrow. But they were thought to be limited. As soon as embryonic stem cells were not discovered, but the way to grow human embryonic stem cells was developed, they applied these technologies, these techniques to adult stem cells, and it didn't work very well. So early 2000, the conclusion is that embryonic stem cells are super powerful. Adult stem cells are not really working very well in regenerative medicine or longevity.
Yeah.
But it was not true. In reality, adult stem cells, if you develop the ways to grow them, to use them, they are actually about just as potent as embryonic stem cells, with one big difference that is actually playing in our advantage, is that in adult stem cells, if you put it in the heart, it becomes a heart cell. You put it in the liver, it becomes a liver cell. You put it in the skin, it becomes a skin cell, and so on. If you take an embryonic stem cells and you put in any tissue, it is so powerful that it has a super high risk of developing a tumor, meaning a lump of tissues that of all parts of the body. So having said all of this, the main difference, embryonic stem cells are made to make in embryos. They don't work therapeutically because they're too wild.
Yeah.
So
if I may, just in terms of people understanding, like the way I kind of think about it is, the embryonic stem cell to say what people are using with placental mesenchymal stem cells, and then adult stem cells. To me, it's sort of it's basically for people to understand what I think of is it's how differentiated. In fact, in how far down the line from having no direction at all to being completely differentiated, going from a cell with no plan at all to becoming a liver cell to a that kind of thing. And so the embryonic stem cell is on the very beginning of that, and then you have the cord mesenchymal cell, and then you have the most differentiated type of stem cell is the adult stem cell. And I think what you're saying is we used to think that we weren't going to get very far with that adult stem cell because it was too far down the line and we couldn't turn it into the things that we wanted it to turn into. But in fact, we can. And if we go to the earlier things like embryonic stem cells, we actually just are increasing the risk of uncontrolled growth, which is tumorigenesis. Is that fair?
It is fair. I will just put a slightly different spin on it.
Uh-huh.
I don't think that the ability to differentiate into various tissues makes adult stem cells progenitor cells, like down the line, if you want. There's still pluripotent stem cells sitting in your bone marrow that are blank, and they can become pretty much anything in the body. The main difference between adult and embryonic stem cells is that if you take one of these stem cells in your bone marrow and you try to grow them, they cannot make another you. They cannot become a full organism. They will sit there until they're pushed to become one tissue or another in your body, but they can become pretty much everything. So they are pluripotent, but they're not totipotent with the ability of regrowing an entire organism, which from a therapeutic standpoint really is the right thing. Like we don't want to be exposed to risk of tumor formation. And in this whole spectrum, I was going to say, in this whole spectrum of stem cells, umbilical cord, placenta stem cells, bone marrow stem cells, V cells, fat stem cells, I mean, these are all so-called adult stem cells. They're all pretty much all the same. Mesenchymal stem cells, it's very delicate to define what is a mesenchymal stem cells because it really depends where you're positioned into the evolution of all this knowledge. Mesenchymal stem cells points to where they're coming from originally in embryonic development. They come from the mesenchyme. But later on, the way to isolate them is that they stick to glass. So the moment we realize that it's very easy to isolate them because they will stick to the glass of a test tube, for example, then when they start to isolate stem cells from other tissues that still start to behave in the same way, then these cells also were called, well, they're mesenchymal stem cells. Then we develop markers that are more specific to mesenchymal stem cells. So at the end, a mesenchymal stem cell is, in many regards, is a lot of different things. But it is a stem cell that to a large, in a broad sense, is either pluripotent or multipotent. It can do a lot of healing in the body.
Certainly one of the advantages, as you've pointed out with adult stem cells, at least in terms of practical application, is they are in our body already. And you mentioned the bone marrow. Where else do you get high levels of these stem cells? My understanding is you can also get it from adipose tissue, from fat.
Yeah.
anything else?
It's a little bit like, prostaglandins. They were
Yeah.
isolated first from the prostate. And then now we know today every single cell of your body makes prostaglandins. It's a little bit the same thing. We first isolate stem cells. We think they're really special. We think that they're there in the bone marrow. Then suddenly, it's interesting to mention that something like 60 years ago, having stem cells in your bloodstream was considered to be a pathology. Like it would be not normal to see stem cells or primitive cells in your blood. And we know today that you release them every day. It's just part of your natural repair and your renewal system. So this knowledge sort of evolves, as we move forward. So where stem cells are in the body, they are in your bone marrow, they are in your blood, but we know right now that they're pretty much in every single tissue of your body. So the question is not where are they? The question is, where is it convenient and effective to go and isolate them?
Right.
And that is really the biggest development right now, is finding sources of stem cells that can be extracted and isolated easily and then can be transformed into a therapeutic treatment. So you've got dental pulp stem cells. Unfortunately, we don't lose that many teeth, in our lives. Hair follicle stem cells. This is something that it's known in science, but a lot of people are not aware that if you take stem cells from hair follicle and you inject them in the spinal cord, you can repair a spinal cord lesion. So they're progenitor cells for hair, but they still have a capacity to become cells of other types of tissues. But again, to extract stem cells from your hair follicles is not necessarily a practice or something that is really done, broadly. But these are sorts of stem cells. So fat tissue is a very common one because they're numerous, plenty of them, and you have easy access. The easiest access is your blood. They are in your blood. We can extract them from your blood. There are different types of them in your blood. V cells are probably the one that are the easiest to deal with in your blood. But we find them in your bone marrow, in your blood, your muscle, your fat tissue, connective tissue. They're pretty much everywhere in the body.
I guess when you're extracting the idea is to create a high, number of them that are functional. Does that change with age? As we get older, is there less stem cells that we can use, or with the with the type of stuff you're doing, mobilize with various methodology?
Yes, that is probably the most important piece of information for us to understand so many things about health, wellness, aging, longevity, disease formation. And it's the fact that these cells that are literally the repair system of the body, anytime you have injury, they're released, they go repair. Any day of your life, you release them, they replace the cells that are being lost in your body. You're born with red marrow that makes stem cells, and very quickly, red marrow converts into fatty marrow that does not make stem cells. And at some point in our 30s, we've lost about 90% of that red marrow. And so, which corresponds to a significant decline in how many stem cells are in the bloodstream to participate to the process of tissue renewal, tissue repair. So we've all experienced that at some point in our 30s, we have an injury, we don't repair or recover as quickly as we used to. It's because of that decline in the number of stem cells. So for the rest of our lives, and as we age, we have fewer and fewer stem cells in our bone marrow, consequently in our blood circulation. And that is why we experience that we don't get better as we age.
Yeah. So when we talk a little bit about the role of the stem cell in the immune response, because you know, part of that I think is important to understand for people, because I don't think necessarily people think of stem cells and automatically think immune system.
Stem cells are part of the immune system in the sense that they are a monocyte. They're lymphocyte. So they are we could call them lymphocyte progenitor cell if we want to really position them into the class of type of cells that they are. But they don't act once they are mesenchymal stem cells, let's say, or any other type of stem cells. They don't typically, as far as I know, they don't revert back and then become cells of your immune system. So it's really hematopoietic stem cells that are the source of red blood cells and also your immune system. Most of the time when we talk about a stem cell treatment, umbilical cord stem cells, fat-derived stem cells, those types of stem cells used for treatment normally do not by themselves feed into the immune system. So they're sort of different class in a way. So your stem cells are indeed part of your immune system. When you boost cell function through mitochondrial function, fasting, a lot of things that can support stem cell function, you will boost your immune system. When you specifically release mesenchymal stem cells or get an injection of these, you don't necessarily have a big impact on your immune system.
So how do when there's an injury, and you're trying to try to help with that injury by mobilization or maybe harvesting stem cells and injecting it, how do stem cells know where to go where there's injury or disease?
It's the same thing that if you have an infection, let's say you cut yourself and you get a bacterial infection in your finger, how will the immune cell know exactly where to go to remove and kill the bacteria? What is happening is that in the area where you have the injury, cytokines are being released that have chemotactic power. Essentially, they attract your immune cells to that area. And when immune cells go into the fine capillaries of the area where you have the infection, they're basically migrating out of your blood system, blood circulation, going to that injury and kill the bacteria. Stem cells are exactly the same. They circulate everywhere in the body, but there is one compound released by any kind of injury, which is called stromal-derived factor 1, SDF1. Stem cells have a receptor specific for SDF1. So when a stem cells circulate in an area where there is an injury and then this compound is being released, when this compound connects with that receptor, it will make the stem cell express adhesion molecule, and the stem cells will cling in the capillaries, stop. And basically, from that process, it's the whole process of migration into the tissue, crawling to the site of the injury and the whole repair response. But they're attracted to that area by SDF1.
And so as we get, and correct me if I'm wrong, then what you're saying is as you get older, because there's less circulating stem cells around, you are effectively unable to respond as effectively to those points of inflammation.
Exactly. That is the reason why, as we age, we experience that we don't repair or recover as effectively or as fast as we used to, let's say in our 20s and 30s or younger.
Before we get into some of your, some of the supplements that you're talking about, like, can we just talk quickly about some of the, the commercial things that you see out there right now, and it's hard for people to tell what's real and what's not real. I personally went to Columbia to BioAccelerator and had mesenchymal stem cells, and actually did a lot of good for me. But the stuff in the U.S., it is a tricky market, and you hear a lot about exosomes. You hear about people, harvesting fat. And can you talk about sort of what the research is behind that? Is there real benefits to, those kinds of interventions where there is a physical harvesting, and then I guess exosomes, you could explain what that is, but it's essentially extract, right? Are those real things, or is that just a big marketing money-making thing?
It's a complex question. Let me try to kind of peel the different layers to
Sure.
that question. So, a lot of this has been driven by regulations. Let me go one step before that. In the not early, at some point in the 1990s, the discovery of the power of adult stem cells started to be made. Like it started to peak. Some scientists reported that adult stem cells really had enormous, amazing regenerative properties. When that started to be recognized, pharma very quickly realized that that by itself was a huge threat to what is today's sort of the medical world. I don't want to attack anybody. I just want this to be like just a very objective observation of the forces that are at
Yeah.
play in the medical world.
Yeah. In other words, they were at risk from this because this is an endogenous product, right?
Yes, but deeper than this, today, medicine, pharma, generally speaking, if you have high blood pressure, I don't necessarily do anything to reverse and change that part of your human body. I give you something that you will take every day for the rest of your life, and that will be the job for you. You have diabetes. I don't ever cure you of diabetes. I just give you and I sell you insulin for every day of your life for the rest of your life. It
Uh-huh.
is an
Yeah.
amazing business model to say, we're not in the business of curing. We're in the business of palliative care to give
Yes.
you a better quality of life for the rest of your life. But you have to pay for this every day. And suddenly comes a modality that is curative. I can actually regenerate your arteries. We can actually regenerate your pancreas. So the moment that the idea that something can come that can truly regenerate, then it meant it is eventually, you just push that thought to the extreme, it means we completely changed our medical world. We go from palliative to curative, which the medical world came with enormous resistance. So the first one was in the media, was to make everybody know or believe that the future is with embryonic stem cells. And that's what a lot of people believed in the first part of the year 2000 until 2013, 15. That's what most people thought. And it was misguided. The future has never been with embryonic stem cells. The idea was that if people think that, it's going to give time to develop the real solution with adult stem cells. But at the end of the day, you can go to a doctor's clinic. They will take your own stem cells, spin them, grow them, give them back to you. The only people that made money is the people selling centrifuge syringes and the doctor. It cuts out the whole
Yeah.
medical
Yeah.
establishment.
Yeah.
So regulations were passed through lobbying to block the development of these treatments and make a lot of people believe that they either don't work or they are risky. None of them are true. It works and it is very safe. So because of the regulations here, a lot has been developed abroad. It's Americans for the most
Sure.
part that went abroad and then developed those treatments. So I'm taking
No,
a
it's
roundabout way to
helpful.
answer your
No, I
question
understand. Yeah. Yeah. I understand.
because when I give you the answer now, it's going to sit on a much greater context. So
Right.
what you have now in America is all the ways that you can circumvent the regulations and also the fear, because you may be doing something that is not illegal, but if the FDA has received pressure from lobbying or whatever to not allow those methods to really develop, they can come and basically audit your clinic constantly. I have friends that have gone through audits numerous times. Nothing was found improper, but the time and the pressure to be audited like this, at the end, they just stop. They stop using it. So it's that kind of pressure on one end, and then the regulations that prevent you how you promote what you're doing that has opened the field to what is now exosomes. Exosomes are not biologics. By this, I mean they're not cells. So suddenly it doesn't fall into a certain class for which there's a lot of pressure to regulate it and prevent it, which is stem cells essentially. So exosomes are essentially the alphabets of of stem cells. So stem cells communicate with each other. So you take stem cells and you make them grow super fast in a test tube. If you take the liquid from these fast growing stem cells and you inject that liquid in another test tube with quiescent stem cells, they will start to proliferate. It's the language. So they communicate through
they're
exosomes.
promoting, just to be clear, what the exosomes in this situation are doing is they're actually promoting the mobilization of the stem cells that a person already has.
It's not, well, you can say it's everything. It's the mobilization, the migration in specific areas, their activation into starting to multiply in an area. To an extent, it could be their differentiation to become cells of the muscle, if they are in a muscle, cells of the skin, if they're there to heal a scar. So exosome is the language of stem cells.
So is there a lot of data? I mean, is this peer-reviewed data on this, that is actually real? I mean, because that's where a lot of pushback comes, is there real data on this? Is this just, things that people are seeing anecdotally and reporting? Case
Exosomes?
reports? Yeah.
Not a lot of research has been done on exosomes per se in terms of their therapeutic potential that I know of, like real studies. The fact that exosomes are the way with which stem cells are communicating, this is not put in doubt.
Yeah.
This is how stem cells communicate. When you inject exosomes in a person, these exosomes will talk to stem cells. If you happen to have few stem cells in an area, then these exosomes don't have a whole lot of people to talk to. So you may say, I had exosomes injected, it didn't do a whole lot to me. And you hear this a lot, and when you inject stem cells, they need to be stimulated by exosomes. So your stem cells will release exosomes. So the real effectiveness of these stem cells also depend on how healthy or how proficient your body is as making these exosomes. So the ideal would be a combination of both. This is really the ideal treatment.
Maybe harvesting and the actual stem cells themselves, and then exosomes, and injecting that. So
correct. That's what I would do if I were to do it.
Yeah. So let's kind of move over to what you're doing now, because you have you have a product. Basically, you say it helps to mobilize, sort of bring these stem cells, endogenous stem cells, into action. Is that effectively what this does? Can you tell us about it?
The best way to answer that question is to talk a little bit of how I came to this. Like, the idea was not stem cells is a cool field. I know this is going to develop, so let's try to make a product that has something to do with stem cells. Really, how all of this started, because my background, as you mentioned, is brain research. So I was studying memory and epilepsy. I have absolutely no training, and I had no training in stem cells. Well, in fact, it is a field that is so new. Nobody involved in stem cell research today got a training in stem cell research. You come from a field, and then you're interested into stem cells, and you dive into stem cells. So what happened to me is that I was hired to study a plant. You may have heard of it, blue-green algae from Klamath Lake, on the marketplace known as AFA. And my job was to document the mechanisms of actions, the active compounds behind the benefits of this blue-green algae, so that companies selling it could use this science to support their marketing claim. Because the DSHEA had been passed, this was 1995, and DSHEA, the Dietary Supplement Health and Education Act, was telling companies, if you make a claim, if you say your product supports the immune system, you need to have data for it. So I was hired for this. So I'll make the story short. As I'm working with this plant, we quickly identified the main mechanisms of action, but I'm witnessing in certain people health benefits that are extremely impressive, in terms of going from a very significant pathology to basically being cured, but with conditions touching, in one person the heart, in somebody else the liver, somebody else's the lung, somebody else's the pancreas, the brain, the retina, the skin, the liver. I mean, it was like so many different aspects of human health that I had no mechanisms of actions. I could not explain what I was seeing. And I did studies to try to understand it for 4 or 5 years, until January 2001, I came across a paper documenting stem cells going from the bone marrow to the brain and becoming brain cells. In 2001, the belief is that stem cells in the bone marrow are only precursors to blood cells. And of all organs of the body, the brain, we know, does not repair. At least that's what we were told. So to see something like this, I thought was impressive. So I went to the local medical library and found two more articles documenting about the same phenomenon in the liver and the heart. So I just thought, if stem cells can become heart, liver, and brain cells, why not pancreas, lung, skin, and the rest? Makes no sense that it will become those three and not the rest. So I thought it's just a matter of time. Scientists will document that stem cells can become everything. So if we assume that they can become everything, they must be the repair system of the body. So we published an article in a journal, Medical Hypotheses, suggesting stem cells are the repair system of the body. And in the back of my mind, just like there are plants stimulating the immune system, what if this AFA, this blue-green algae, was stimulating the repair system? So we bought a flow cytometer and a machine to count stem cells so that we can accurately quantify stem cells in the blood. So we took a blood sample on ourselves before and then an hour, 2-3 hours after consuming this AFA, this blue-green algae, and then we saw the whole phenomenon. So this plant was triggering the release of stem cells from the bone marrow. So, and then over the years, I've identified more than five, but I'm using now the 5 top plants that I've studied over the years that act as stem cell mobilizers, putting more stem cells in circulation. So what it means, if I tie this to the rest of the discussion that we had before, when you get an injection of stem cells, at the end of the day, the only thing that is truly achieved is that we have increased the number of stem cells in circulation through an injection. So what we're talking about here is increasing the number of stem cells in circulation, not through an injection, but by using a natural phenomenon, which is the release of our own stem cells from our own bone marrow.
What were the, what were the specific agents within the specific chemicals that you think that are actually increasing that number of stem cells in the blood?
You mean the compounds in this?
Yeah, the
blue-green
compounds.
algae?
Yeah.
Well, we had, when we published this, so the first time when we got the data, then it became very clear that the first reaction from scientists was that this is nonsense. Nothing can have an effect on stem cells. Then the next obstacle was that, well, maybe it has an effect on stem cells, but if you put more stem cells in circulation, it doesn't mean anything. So we had to do a proof of concept to show that it stimulates release. Then, okay, maybe it's good for you, but maybe it's also bad for you because maybe it promotes cancer. So we had to go through many years of all of these studies to really document the mechanism of action, the active compound, proof of concept, safety, and all of that. So with this blue-green algae, it's with this plant that we've done the most work. So blue-green algae as an L-selectin blocker. L-selectin plays a role in this receptor that we talked about before that connects with SDF1 when a stem cell migrates in a tissue. But in the bone marrow, it plays a crucial role into the maintenance of stem cells in the bone marrow. So when you interfere with this, then you basically make stem cells detach from the bone marrow matrix. So we have an L-selectin blocker. This is what we have in the blue-green algae. In other plants that we have documented, their effect on stem cells, it's other mechanisms of action. There is about 2 or 3 different types of mechanisms of action that all end up affecting that connection that we talked about before. So you can block the L-selectin. You can also have compounds that will mimic a repair or an injury response. So just like you have, for example, fasting mimicking compounds that stimulates autophagy, in the same way, you have compounds that will stimulate what we can pick up in the blood as a repair response. Like you take the product and within a few hours, you see stem cell factor showing up in the blood. Your body has no injury, but it mimics like an injury response.
So tell us a little bit specifically more about, so the way you did that, my understanding, so you use flow cytometry to basically document an increase in stem cells in the blood. How long did that effect last? Did you see it go? Were you able to see this? Did you just assume then that it was circulating through all the organs, or was there a way to show that it was actually going through the blood-brain barrier and affecting the brain? Or
the research was not there at the time, and And I was working on a very, very different, how could I say? The whole situation was very different than how you normally do medical research. What I mean is that you develop a molecule or you isolate a molecule. You want to know if it's going to work. So now you need to test if it's going to have an effect on stem cells. Will that mean anything for health? And all of that. For my situation, I started from the other way around. I already saw that this product had an amazing effect on some people's heart condition, other people's pancreas, and various tissues of the body. So my point is that I saw that it was happening. I just did not understand how it was happening. So the moment that we document the effect on stem cells, and you couple this with all the studies that are present in the scientific literature, and there were at the time quite a bit, since then, way more. I mean, we're talking about thousands of studies documenting the link between how many stem cells you have in circulation and the body's ability to repair. There's a direct link. You put more stem cells in circulation, your body will utilize these stem cells for repair. So the moment we can document that we have an herbal compound that makes you trigger the release of your own stem cells, and we can quantify more stem cells in circulation, that narrative plugs into tons of research already
Right.
available. So our role then was to do the next step, which is, okay, then let's document it in specific health conditions.
Like in clinical
So-
trials or
Correct.
Okay.
Correct.
Yeah.
So now we have started clinical trials. So we have two of them ongoing. One is on stable chronic congestive heart failure. The other one is on Parkinson. We have a few others in preparation on emphysema or COPD. One is on liver failure. We have colitis. So all of these are in preparation. But right now, on what we have on heart disease, studies that are at least the preliminary report, one of them we will submit for publication soon, but on 10 patients so far with stable chronic congestive heart failure. So wherever they were at that point is whatever medicine could do with them. And all we did is that we put them on our product that triggers the release of stem cells from the bone marrow, 2 capsules 3 times a day. And after 6 months, all 10 patients after 6 months have normalized heart function. Sort of
Yeah.
they regain normal heart function. So we are showing the repair on the heart. We have similar data on Parkinson, and it will continue to show like these different types of condition, not to show that the product is good for these diseases. That's not the point at all. We will never make the claim. The claim is just to show that the number of stem cells that you have in your bloodstream is directly linked with your ability to repair. And if we can put more stem cells in circulation, your body can indeed use these stem cells for repair and see what it has done in the cases of people who had heart problems or brain problems or lung problems and so on.
So a lot of the data is yet to come, and I guess we'll just see. I mean, you have preliminary data, but presumably you're looking to, publish this data in peer-reviewed journals.
Sure.
Yeah. Should we expect that the effect of this supplement would probably go down with age, since the absolute amount of adult stem cells probably reduces? And so at some point you've essentially, you just don't have enough to even stimulate to get out.
Yeah, that's where I started 20 some years ago. That's what I thought. That's what I assumed. That's what I expected. 20 some years of working with these products is absolutely not the case. It is still true that you have fewer stem cells in circulation. It is true that the stem cells that you have, not only you have fewer, but they're not as effective as when you were young. But the conclusion out of these observations to say, therefore, past 40 or 50 years of age, your stem cells are worthless is absolutely untrue. The studies that I just mentioned, congestive heart failure, in that study group, those 10 patients, it was before 55 and 76 years of age. The group on Parkinson is the same kind of age brackets. So, and all the stories and all the single patient outcomes that we have seen over the years, by all means, my best way to conclude, to summarize the data that I have seen over the years, is that at any point in your life, if you can put more stem cells in circulation, your body will use it. If you get $1,000 in your pocket and I double it, great, you got $2,000. But if you've got $20 and I double it and you got 40, you'll make twice what you could do with your $20.
Right.
And if I give that to you every day, there's a cumulative impact of this over time that can be extremely significant in people's health. We've seen it.
What is the product called?
The product is called STEMREGEN Release.
And where can you get that?
On our website, so stemregen.co, stemregen.co. That's where you can get it. You'll see there's more than one product, and the idea here is that I've worked with product that releases stem cells for many years, for 2 decades, and I have seen many times there are cases in which you don't see the full benefit or what you would expect from people's releasing their own stem cells. And if I do a small parenthesis, in a lot of my lecture, I show this video that I find absolutely mind-blowing. So it's the group of Doris Taylor. They isolated the heart of a mouse, and they completely digested the cardiac muscle with digestive enzymes. So after, a day, everything is digested. They're simply left with the soft skeleton of the heart, the connective tissue of the heart. And on that connective tissue that still retains the trace that it was a heart, they lay stem cells taken from that animal. And a week later, you have a beating heart in a test tube. This is powerful. This is kind of revealing the raw regenerative power of bone marrow stem cells. So the question is, why don't we see all that regeneration in the body? What stands in the way of stem cells showing this full regenerative power? We see it in patients we have like full recovery, but why is it not happening in people who have chronic conditions, for example? Why these conditions remain chronic? And there's 2 things that will come immediately to mind. Number 1, systemic inflammation. Your signal that is telling stem cells where to go, which should be localized to tell stem cells where to go, is now systemic. Stem cells are blinded in their ability to find where they need to go, number 1. Number 2, a chronic condition due to its inherent inflammation that is taking place, oftentimes have also a declined or let's say reduced microcirculation, impaired microcirculation. Stem cells can go to 20 microns or more. Your capillaries 12 microns. For stem cells to reach the area that needs repair, there's just a lot of things that needs to align. So we've created a product that works to really opening the microvasculature. So that's kind of what you will see on the website when you see these different products.
Fantastic. And again, the book is called Cracking the Stem Cell Code. Dr. Drapeau, thank you so much for joining me on Longevity Roadmap today.
It was a pleasure. Thank you.
Thanks for listening. A quick reminder that while I am, in fact, a surgeon, nothing I say should be construed as medical advice. Now, make sure to include your physician in any medical decisions you make. And also, if you're enjoying the show, please make sure to show your support with a like, share, or subscribe.